Last category is arc length, which I believe is similar to something we've already done before. So it's just review, I think, unless I'm just forgetting what I did with you guys in person. But either way, let's do some examples of this. So in a circle G, so that's the circle, with measure of FGH, this angle, has 74 degrees, and FG, wait, let me see, FG, I'll do in blue, is 8 units. Find the length of arc FH. Okay, so in case you guys forgot this formula, the formula is arc is equal to central angle over 360, because that's the portion of the entire circle. The entire circle is 360. And then you're going to multiply this by the circumference, which is 2 pi times r. So actually, I should do that in black. 2 pi r. R stands for radius. Okay, so your arc length is equal to the central angle divided by 360 multiplied by your circumference, which is 2 pi times the radius. So this is the formula. I believe we introduced it last time. If not, here it is again. We're finding the length of the arc. So arc is equal to the central angle. It's color-coded. So the central angle is 74 degrees over 360 multiplied by 2 pi, and the r, which is your radius, is given to us as the length of FG, which is 8. And so we're going to type this into your calculator, and we're going to round it to the nearest hundredth. So let me go pull up that calculator. There we go, and then clear all that. 74 over 360 times 2 pi. Pi is right here on the calculator. Okay, and then once we type that out, we get, let me write it out, 10.332. Okay, so 10.332, I mean, it has more, but if we're rounding it to the nearest hundredth, we want 2 decimal places. So we're thinking of cutting it off, I'm not annotating. We're thinking of cutting it off right around here. So depending on if that 2 is big or small, we're going to keep or change the 3. 2 is small. So therefore, you're going to keep the 3 as a 3. So it's 10.33. 10.33. Oh, that bothers me so much. There we go, 10.33. Any questions on this one? Let's do 2 more examples. So let me annotate, do some erasing. Okay. All right, so we have the angle is equal to 60 degrees, so that's over here. The measure of LM, that's 17 units. And then we're finding the length of the arc, LN. So the arc is equal to, we still have the same old formula, so that's why I didn't erase it. Central angle is 60, radius is 17. Type it into the calculator. Once you type it in, you get 17.802, or at least that's what I get, because I have a different question from you, so please don't write this down. Unless it's just for notes, of course. I meant don't type it in as your answer. Okay, so 17.802 rounded to the nearest hundredth means 2 decimals. So we look at the 8, 0. Are we changing or keeping the 0 based on this 2? The 2 is a small number, So therefore the 0 stays as a 0. We want 17.80. All right, any questions on this one? Next one. Last one. Okay, so of course I keep the same formula there because we're still using the same formula. So the circle M with measure of angle LMN is 60, and measure of angle, measure of the segment LM is 15. Find the length of arc LN, round to the nearest hundredth. So we're going to get 2 decimal places. So we have our central angle, 60. We have our radius, 15. Plug it into the formula. Nice and easy. And then, oops, I forgot to erase the old answer. This is like the last answer. Okay, so I'm going to go ahead and type that into your calculator. $60 over 360 times 2 pi 15 gives me 15.707. Okay, so we want it to the nearest hundredth. That's 2 decimal places. So we're looking at the 0 and we're seeing, do we want to keep it or change it based on that 7. So that 7 is a big number. Remember, big's 5, 6, 7, 8, 9. Small is 0, 1, 2, 3, 4. So 7 is a big number. Therefore, that 0 gets rounded up to a 1. So our final answer is 15.71. Any questions on our last example? All right, so for this one, that was it for this category. I think that was it, right? Yep. All right, so you guys are free to keep working for the rest of the period.